mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
Something has slipped into our solar system that refuses to behave like anything we have seen before. It is racing at over 61 kilometers per second, already deep inside Jupiter's orbit and closing in on the Sun.
The supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Traced back to the same region of sky that once produced the unexplained wow signal, its strange glow and sudden surges have left scientists unsettled. Could this be the first clue to the alien arrival we have long feared? Stay with us to find out. The interstellar visitor we almost missed. Something huge has been moving toward us for months, and no one saw it. A 10-kilometer object wrapped in a ghostly cloak of dust slipped past the very systems built to protect us, entering the solar system in silence until July 1st, 2025. By the time it was finally flagged, it was already inside Jupiter's orbit. That is, closer than anything this alien should have ever been, forcing astronomers to ask the question they dread most. What else have we failed to see? This is the 3I-ATLAS, a nucleus nearly 10 kilometers across, wrapped in a 20-kilometer cloud of gas and dust, and it is traveling at 61 kilometers per second. By the time the Atlas telescope in Chile's Rio Hurtado Valley flagged it as a strange, unidentified blip, it was already inside Jupiter's orbit at 2.56 astronomical units, being pulled closer by the Sun. The discovery was no accident. ATLAS, NASA's Asteroid Terrestrial Impact Last Alert System, uses 4 robotic telescopes spread across Chile, South Africa, and Hawaii, each capturing more than 800 images a night. Together, they track over 1,200 near-Earth objects, any of which could pose a risk. Unlike other surveys, such as Pan-STARRS or Catalina Sky that avoid the dense galactic plane, ATLAS can scan directly into its glare. That ability proved crucial. In the crowded star fields of Sagittarius, 4 30-second exposures caught something moving with a straight, undeniable path toward the inner solar system. The data was rushed to the Minor Planet Center in Cambridge, Massachusetts, which confirmed the motion and issued an urgent circular. Soon, other observatories joined in. The Zwicky Transient Facility in California and additional ATLAS outposts uncovered faint traces of the same object in images going back to the 14th of June. With those earlier sightings, the orbit was calculated, hyperbolic, with an eccentricity of 6. That single number revealed it was not bound to the Sun at all. It was interstellar. This made it only the 3rd confirmed visitor of its kind, after Oumuamua in 2017 and Borisov in 2019. The official designation became C/2025N1, its cometary nature confirmed by a faint coma produced as surface ices began to sublimate. Astronomers quickly mobilized to learn more. On the 10th of July, the Las Cumbres Observatory in Hawaii tracked it for an hour, detecting a steady 29-hour rotation with little brightness variation, unlike Oumuamua's chaotic tumbling. Its brightness had already surged from magnitude 20 in late May to magnitude 17.7 by the time of discovery. Less than 2 weeks later, on the 22nd of July, the Vera C. Rubin Observatory delivered precise measurements showing early cometary activity, a faint tail extending more than 25,000 kilometers. Amateur astronomers soon confirmed the reddish hue of its dust, resembling D-type asteroids of the outer belt, the same kind of spectrum Borisov once displayed. All of this left scientists unsettled. An object this large, this fast, and this rare had slipped past the very systems designed to catch it. And as its path was traced back to Sagittarius, the same region of sky linked to some of astronomy's most puzzling signals, the discovery raised an even darker question. Had this visitor really gone unnoticed by chance? Or was there something about its silence we were never meant to miss? The Sagittarius connection. Something about 3I-ATLAS doesn't add up, and astronomers are about to be put on the edge of their seats with this discovery. That link to Sagittarius alone set off alarms, because Sagittarius is not just another star field, it has a history of anomalies. One of the most famous was the WOW signal. On 15 August 1977, the Big Ear Radio Telescope in Ohio detected a powerful signal at 1,420 megahertz, the frequency of neutral hydrogen, the natural hailing channel of the universe. It lasted 72 seconds, long enough to rule out random noise, then vanished without a trace. The astronomer who found it, Jerry Eman, circled it in red and wrote one word in the margin: "Wow." Nearly 50 years later, the mystery has never been solved. Now fast forward to 2025. RxIve papers published in early August confirmed that 3I-ATLAS is not bound to the Sun at all. Orbit is hyperbolic, meaning it came from interstellar space and is now simply passing through. Is this a coincidence? Some astronomers think so. Others are not so sure. New observations only deepened the unease. On 15th July, Gemini North captured one of the first clear images of the object. Instead of the usual reddish hue of cometary dust, the edges glowed faintly green. Some researchers said this was just a chemical quirk of sublimating ice. Others suggested the spectrum hinted at something engineered, almost like camouflage. Avi Loeb of Harvard quickly weighed in. On 12th July, he published a commentary calling the alignment a scripted convergence, arguing that the odds of a hyperbolic visitor emerging from the same sky patch as the WOW signal was far too small to ignore. Critics dismissed the claim as speculation, but then more data arrived. Archival images from NASA's TESS satellite, taken in late June but released in August, showed faint traces of the object before its official discovery, almost as if it had been skirting the edges of our detection network. By early September, the mystery grew. NASA's Psyche spacecraft crossed within 0.302 astronomical units of 3I-ATLAS, close enough to monitor its activity. Reports showed no sudden velocity shifts, but did detect faint thermal emissions that did not fit standard comet models. And in mid-September, ground-based observatories reported that the object was brightening faster than predictions, holding visibility longer than expected before moving into the sun's glare. For many astronomers, the timing and location are impossible to dismiss. The same part of the sky that gave us unexplained signals now delivers a physical visitor, moving in ways that raise more questions than answers. And as solar heat begins to stir its surface, this story is only getting stranger, because what 3I-ATLAS is about to reveal could overturn everything we thought we knew about interstellar visitors. The comet that won't play by the rules. Following a new series of tests and discoveries, this visitor showed that it doesn't play by the rules. Could it be the slightest sign of the talked-about alien invasion? As sunlight hit its surface, astronomers expected the usual: a slow release of gas and dust, like an ice ball gently melting. Instead, the object erupted in sudden bursts, breaking every model scientists have of comet behavior. The first signs came on July 22nd, when Vera Rubin Observatory flagged a faint haze forming around the nucleus. Normally, a comet that close to the Sun would already be shedding water ice steadily. But 3I-ATLAS stayed quiet, then jumped without warning. The Very Large Telescope in Chile logged a dramatic surge on August 25th, Gas density tripled overnight. That is not how comets act. The puzzle deepened with Hubble's early July images. Instead of a steady curve of dust release, the data showed erratic swings, up one day, down the next. Las Cumbres Observatory tied those outbursts to its unusually calm spin rate, about 29 hours per rotation, far smoother than the chaotic tumbling seen in most small bodies. A calm surface should mean even activity. Instead, scientists are seeing controlled bursts. Some astronomers suggest exotic ices buried deep inside, held under pressure until sunlight finds a weak spot. But the timing looks too precise to be random. Avi Loeb, known for pushing bold ideas, described it in September as a resonant pop, as if the object's interior was tuned to respond in cycles rather than melt naturally. That kind of phrasing unsettled people, especially with memories of Oumuamua, which ejected nothing at all. This pattern raises a troubling question. Are these bursts simply chemical reactions, or is there something deeper at work? The surge curves suggest triggers beyond sunlight, internal pressures, structural weaknesses, or something we do not yet understand. Each new data point sharpens the unease that 3I-ATLAS is not just reacting to heat, but responding, as though following an internal clock. And now, inside that growing haze, fresh chemical signatures are beginning to appear. Strange metals, odd ratios, and readings that do not fit expectations. The deeper the scientists look, the less it resembles a natural comet, and the more it feels like something designed to be noticed. And if you're just as unsettled as astronomers are right now, hit that like button. It lets us know you're ready to keep digging deeper into this mystery with us. Nickel without iron, an impossible signal. Just when scientists thought that 3I-ATLAS couldn't be hiding anything more up its sleeves, they discovered what shocked them to the core. Astronomers using the Very Large Telescope expected the usual blend of cosmic metals, nickel paired with iron, oxygen in the mix, maybe even faint carbon bands. Instead, the data showed something that should not exist in nature: pure nickel gas glowing brightly, while iron and the other expected elements were nowhere to be found. This absence matters because nickel and iron are born together in the same violent events, like supernova explosions. Every asteroid, comet, or fragment studied so far carries both metals bound tightly, never one without the other. But 3I-ATLAS breaks that rule. Its spectrum lit up with nickel alone, standing out like a fingerprint drawn too carefully to be random. But the anomaly didn't stop there. As 3I-ATLAS traveled between 3.9 and 2.85 astronomical units from the Sun, the nickel emissions flared with clock-like precision. The rate at which nickel was released followed an unusually steep curve, shrinking with distance in a way far too exact for the messy, uneven evaporation seen in natural objects. It looked less like a random meltdown and more like a controlled system opening vents on cue. Astronomers called it a picked release. They pointed out that nature doesn't selectively isolate one element while hiding all others. Human engineers, however, do. The pure nickel resembled high-grade alloys that engineers manufacture for spacecraft hulls and heat shields, designed to survive extreme heat without breaking down. Then came another puzzle. Light reflecting off the surface of 3I-ATLAS showed strong negative polarization, a pattern linked to smooth, uniform materials almost like polished coatings or engineered panels. Natural rocks tumbling in space usually scatter light chaotically because of their uneven cratered surfaces. Hubble confirmed this finding on the 10th of September 2025, ruling out any chance of faulty readings. Even its origin raises eyebrows. Calculations place 3I-ATLAS in the galaxy's thick disk, a region filled with ancient stars and objects as old as 11 billion years. That means this fragment could predate much of our solar system, yet its purity looks more like the work of a workshop than the aftermath of a supernova. Loeb's earlier preprint on the 17th July estimated the odds of artificial design at 10 to 1 against a purely natural explanation. Skeptics tried to explain the nickel spike as a trick of dust or interference from nearby material, but the numbers refused to bend. And just as the debate heated up, another element burst onto the scene. To some, it felt less like a cosmic accident and more like a warning system hidden inside the object itself. But which new element is that? The cyanide spike, a signal too precise. Just when astronomers thought the nickel discovery was strange enough, another element forced its way into the spotlight: cyanide. This highly toxic gas began rising in perfect step with the nickel surge, its levels climbing sharply instead of drifting upward slowly, as a natural comet would when heated by the sun. The timing was so precise, it looked less like random evaporation and more like an internal switch being flipped. Normally, cyanide is not unusual in comets. Many of them release small amounts when sunlight breaks down frozen organics. But 3I-ATLAS was different. The volume of cyanide released was massive, and it happened in sync with the nickel spike as the object closed in at 2.85 astronomical units. Measurements showed a cyanide-to-water ratio that was completely off balance, far higher than seen in any natural comet. To some researchers, it resembled the breakdown of synthetic materials, coatings, sealants, or adhesives designed to withstand extreme conditions and then release chemicals in controlled bursts. Avi Loeb quickly pointed to this possibility in his latest write-up. He suggested the cyanide release might not be natural at all, but a trace of engineered materials. In that model, specialized coatings would vaporize at exact heat thresholds, explaining why cyanide appeared suddenly, why nickel was exposed, and why iron remained hidden. This theory made the object feel less like a frozen rock and more like a machine, revealing parts of its design under solar stress. The anomaly also drew in more powerful eyes. Teams prepared to use the James Webb Space Telescope in September to hunt for isotopic signatures, chemical fingerprints that could confirm whether the object truly came from the galaxy's thick disk, a region filled with relics as old as 7 billion years. If the material inside 3I-ATLAS proved that it was ancient and still carried engineered-like traits, the implications would be staggering. It behaved more like a controlled system venting deliberately than ice slowly boiling off. Upcoming observations from SphereX are expected to scan for any telltale deviations in the spectrum that could expose whether the gases are engineered exhaust rather than accidental evaporation. And just as scientists scrambled to explain the cyanide surge, another wave of gas entered the mix. The sheer volume and timing piled even more weight on the idea that 3I-ATLAS was not shaped by chance, but by purpose. Carbon dioxide surge, the loudest clue yet. If the cyanide spike already felt unnatural, what came next pushed suspicion into overdrive. Beneath that toxic surge, astronomers detected an even heavier burst of carbon dioxide flooding out in quantities no comet has ever shown before. Levels soared 30% above the upper limit, expected for natural outgassing, not in steady streams but in erratic pulses that refused to match the comet's distance from the sun. Instead of behaving like buried ice slowly thawing, the release looked like sudden venting from compartments buried deep inside. The Smithsonian-linked telescopes recorded the anomaly on August 28th. Their data revealed ratios so skewed that comparisons to Borisov, the interstellar visitor of 2019, collapsed instantly. Borisov's carbon dioxide output had followed predictable patterns. 3I-ATLAS, by contrast, produced irregular spikes, almost as if valves were opening and closing, to meter the gas in controlled bursts. The behavior mirrored the kind of scrubber systems or fuel cells humans build to trap and vent carbon dioxide during long-duration missions. Scientists argued that the surge was less a peculiarity of natural ice and more a signature of relic technology, industrial-grade systems built to endure billions of years in hostile space. In this view, the pulses were not random, but the slow leak of storage tanks or shielding compartments, only opening under the heat of the sun after a journey from the galaxy's thick disk. Objects from that ancient region can be between 3 and 11 billion years old, tough survivors of the universe's earliest epochs. The spikes further pointed to compartmentalized storage, internal chambers isolating gases until precise thresholds were reached. That possibility raised troubling questions. Were these chambers part of a propulsion system or preservation measures designed to keep the object intact across unimaginable distances? Gemini's September imaging of the comet's tail added fuel to the fire. On the surface, the coma resembled that of a typical comet, reddish and diffuse, but underneath the resemblance broke apart. Data hinted at controlled gas release without the chaotic breakups or fragmentations seen in ordinary bodies. Even Psyche's September 4th flyby analysis, shared through early RxV papers, reinforced the odd stability. Despite immense stress, there were no violent ruptures, just consistent venting that suggested design, not decay. By this point, the carbon dioxide surge had shifted from a supporting detail to the loudest clue yet. It was not whispering about a frozen relic of deep space. It was shouting about systems built for endurance. And as the first faint glimmers of light began breaking through the haze around its core, astronomers were left staring at the possibility that 3I-ATLAS was not just carrying secrets, it was alive with intent. And the next discovery will leave astronomers and scientists in utter shock. If that revelation left you stunned, don't keep it to yourself. Share this with your friends so they can see just how deep this mystery goes. A glow that shouldn't exist. Objects drifting through space don't make their own light. They shine only because the sun hits them. But 3I-ATLAS is breaking that rule. Its glow is stronger than physics says it should be. It is so strong that astronomers are being forced to ask if something inside it is actually generating power. The first warning came from Hubble on July 18th, when the images confirmed the nucleus was only about 10 kilometers wide, too small to account for the excess brightness. For it to reflect that much light naturally, it would need a surface area far larger than what's been observed. That leaves only one explanation: an internal source of energy. Avi Loeb was blunt about the implications in an August 17th interview. The excess luminosity fits a nuclear signature like a glove. He pointed to scenarios like radioisotope decay or even remnants of fusion technology, either of which could produce low but steady heat over billions of years. Supporting this are polarization measurements, patterns in the way the light is scattered, that don't line up with ordinary dust reflection, but could hide the faint thermal hum of a power source. Mainstream teams pushed back, insisting the glow could still be sunlight bouncing off unusual surface coatings. But Loeb countered with a September analysis showing that without thermal data, reflected light alone doesn't close the gap. And here's where the James Webb Space Telescope comes in. It is scheduled to gather spectra that could reveal heat pockets invisible in optical wavelengths. If those thermal anomalies exist, it would be the same kind of unexplained push seen with Oumuamua, which sped up without any visible dust jets to account for it. The next critical checkpoint will be when NASA's Mars Reconnaissance Orbiter aims its high-rise camera during a close pass of just 28 million kilometers. Thermal maps from that flyby could confirm whether the glow is emission, not reflection. If so, 3I-ATLAS would no longer be a passive drifter. It would be a powered object, carrying energy systems that have endured since the galaxy's early thick disk days, potentially billions of years old. Just when the idea was dying out, Loeb came up with another startling input. He said the object's brightness profile cannot be explained by sunlight reflection or standard cometary outgassing. Instead, he suggested, 3I-ATLAS might be generating its own light, possibly from nuclear energy. He further opined that 3I-ATLAS could be a spacecraft powered by nuclear energy, and the dust emitted from its frontal surface might be from dirt that accumulated on its surface during its interstellar travel. This cannot be ruled out, but requires better evidence to be viable. Loeb dismissed other natural power sources. A primordial black hole, he said, would generate only about 20 nanowatts, far too weak. A radioactive fragment from a supernova was highly unlikely given its rarity, and frictional heating from interstellar gas and dust was ruled out by momentum and density constraints. That leaves the simplest explanation of a central, compact, high-power source. The most natural way to achieve the gigawatt-level luminosity observed would be nuclear power. And the unsettling part? Its trajectory through the solar system feels almost too deliberate, as if it were charted long before humanity ever had the tools to notice. The route that shouldn't exist. What if the strangest part of 3I-ATLAS is not its glow, but the path it cut through our solar system? A path so clean and deliberate that it looks less like random cosmic drift and more like a charted mission. The object followed the ecliptic plane, the flat disk where all planets orbit the Sun. But here's the catch. It did so with only a 2-degree tilt. For a natural interstellar visitor, the odds of slipping in at that exact angle are close to impossible. It is the kind of precision engineers build into their probes, like Voyager, when they send them on carefully planned flybys of multiple planets. And this wasn't a sloppy pass. Orbital analyses published on Archive on the 21st of August mapped its course as hyperbolic, meaning it came in fast from outside our solar system. Its entry wasn't from a random direction either, but from the galaxy's thick disk, a region above the thin disk where most stars, including our Sun, reside. That alone sets it apart from Oumuamua, which approached from the direction of Vega, or Borisov, which curled in from Cassiopeia. Astrophysicist Avi Loeb has called this a possible dark forest tactic, the perfect way for a scout to enter, gather intelligence, and leave without drawing attention. No gravitational nudges from planets can explain such a smooth, efficient path. Simulations show it would require active course corrections, the kind our own spacecraft attempts with thrusters or solar sails. And the story isn't finished. The European Space Agency's JUICE probe is scheduled to pass near 3I-ATLAS in late 2025. If it detects even the slightest deviation, something gravity alone cannot explain, the suspicion of design will only deepen. Each leg of the journey points toward intent, raising the question no one wants to answer too quickly. Was this truly random? Or did someone, or something, plan it long before we noticed? The Mars flyby that could expose everything. On the 3rd of October, 2025, Mars will become the stage for a close encounter that could answer the question no one wants to ask out loud. Is 3I-ATLAS just another rock, or something far more deliberate? 3I-ATLAS will pass uncomfortably close to Mars. Not close enough to strike, but close enough to be watched in detail, about 30 million kilometers out. For the first time, astronomers may capture a clear image of an interstellar visitor from a planet's front yard. NASA's Mars Reconnaissance Orbiter will train its high-rise camera on the object. This powerful lens can resolve details as small as 30 kilometers. That might sound coarse, but when applied to something this alien, even a few pixels could reveal whether its surface is the product of natural impacts or something more deliberate. The European Space Agency's Trace Gas Orbiter will also be on alert, sniffing the thin atmosphere around Mars for unusual chemical traces as 3I-ATLAS passes. If there is outgassing, even faint plumes of carbon dioxide or other compounds could be detected. This encounter ties directly to the object's suspiciously precise trajectory. Unlike Oumuamua, which zipped by before telescopes could lock on, 3I-ATLAS is giving us time to prepare. And unlike Borisov, which looked and behaved like a normal comet, this one has already broken expectations. In mid-September, its brightness surged more quickly than models predicted, reaching magnitude 12 to 13 and holding steady until the sun's glare made it invisible. That sudden flare suggests active processes at work, possibly outgassing, but of an unusual kind. These differences hint that 3I-ATLAS may carry a composition shaped by conditions far beyond our local star. Some researchers suggest it could be a leftover fragment from ancient planet formation in another system, a fossil of worlds that never fully formed. The Mars Pass matters because it is humanity's best chance to gather decisive data before the object swings closer to the Sun. If the Trace Gas Orbiter or rovers on Mars detect unusual signatures, it could push the mystery even further. The stakes are high because astronomers have missed chances before. Oumuamua left us only with speculation, and Borisov faded without surprises. This time, the instruments are ready. The question is whether 3I-ATLAS will reveal itself or slip away, leaving us chasing shadows across the sky. But if 3I-ATLAS reveals surfaces that look anything but natural, we'll be staring at proof that our solar system isn't as empty as we thought. That moment could mark a turning point in human history, the day we realized the visitors we've been waiting for may already be here. Do you believe the Mars flyby will deliver that kind of shock? Or will it leave us with more questions than answers? Share your thoughts below in the comment section. And don't forget to subscribe so you don't miss what could be the biggest revelation of our time. Because the next chapter of this story could change everything we know about our place in the universe. Thanks for watching. See you in the next one.